In this video, we will discuss applications of expected value to investments, business, and insurance. We're going to start off with an example. Nick has $5,000 to invest and will commit the whole amount for 6 months to one of 3 stocks. A number of uncertainties could affect the prices of those stocks, but Nick's research suggests that he has figured out the most likely scenarios. Find the expected profit or loss for each stock and select Nick's optimum choice. So here we have information about the 3 stocks. The first one, ABC, he could lose $400 20% of the time, or gain $800 50% of the time, or gain $1,500 30% of the time. For RST, he gains 580% of the time and 1,000 20% of the time. And for XYZ, he breaks even 40% of the time, gains 730% of the time, gains 1,200 10% of the time, and 2,000 20% of the time. So the solution is to first calculate these expected values. The expected profit from stock ABC is $770. The expected profit from stock RST is $600, and the expected profit from stock XYZ is $730. So Nick should invest in stock ABC as it has the largest expected profit. Note, in this last example, Nick could lose $400 over the 6 months. The expected profit is, as previously described, a long-term average and no guarantee of profit. Using expected values may not be the best approach, particularly since this investment situation may never occur again. 2 alternate investment strategies are pessimism and optimism. An optimist ignores most probabilities and figures out the best each investment could do. A pessimist instead focuses on the worst possibilities. So, in the last example, which stock should Nick pick if he is an optimist or a pessimist? If Nick is an optimist, he will pick the investment with the best possible outcome. For ABC, the best outcome is $1,500. For RST, it's $1,000. And for XYZ, it's $2,000. $2,000 is the best outcome, so Nick would buy XYZ, even though it's only a 20% chance that he would actually get those $2,000. He is, in fact, a lot more likely to break even, twice as likely to break even. If Nick is a pessimist, then he picks the best of the worst possibilities. The worst possibility is a $400 loss for ABC, a $500 gain for RST, and for XYZ breaking even. As a pessimist, Nick would pick RST. Now, personally, I would also pick RST because with RST, you are guaranteed to make money, assuming his calculations are right. There is no way of losing money if you choose RST, and maybe it doesn't have as high a potential payout as any of the others, but 4/5 of the time, you're going to make $500 on your $500 investment, so you come out way ahead. Now we'll move on to a business example. Mike is considering the purchase of a truckload of varied dimensional lumber. He calculates that the probabilities of reselling the load for $10,000, $9,000, or $8,000 are 22%, 33%, and 45% respectively. In order to ensure an expected profit of at least $3,000, how much can Mike pay for the load? So first, we find the expected revenue, or the expected income from the sale of the lumber. We do that the same way we've been doing it. We take the income and the probability and we add it all up. And that comes out to an expected revenue of $8,770. To find the expected profit, we use the general formula, profit equals revenue minus cost. So $3,000 equals $8,770 minus the cost. We switch the place of the 3,000 and the cost to get 8,770 minus 3,000 is $5,770. Mike can pay up to $5,770 and maintain an expected profit of $3,000. Doesn't mean he'll make the $3,000, but that's his expected profit. One last example. Jeff will realize a profit of $150,000 on his wheat crop unless there is rain before harvest, in which case he will realize only $40,000. The long-term forecast assigns rain a probability of 16%, or 0.16. An insurance company offers crop insurance of $150,000 against rain for a premium of $20,000. Should he buy the insurance? So to make our decision, we compute expected profit under both options, to insure and not to insure. So when insuring, in the case of rain, his net profit is $170,000. That's the $40,000 he would make selling the wheat, plus the $150,000 he got from the insurance company, minus $20,000 for the cost of the insurance. We multiply that by the probability and get $27,200 as the product. If there's no rain, he gets the $150,000 for selling off his grain and loses $20,000 for paying for the insurance that didn't come through. And that's an 84% probability, so that has a product of $109,200. The expected profit here is the sum, $136,400. Now, if he chooses not to insure his crop, if there's rain, his net profit is $40,000. It happens 0.16, 16% of the time, that's $6,400. If there's no rain, his net profit is $150,000, which happens 84% of the time for a total of $126,000. The expected profit is then $132,400. By comparing the expected profits, we see that Jeff is better off buying the insurance. I mean, we can also just look at the total amounts of money he could get here. If we add these up, he has $300,000. If we add these up, he has $190,000. He's a lot better off here.